All right. So we are here today, July 27th. This is day 3 of the workshop, and we're still all alive and mostly happy. So today we're going to be talking about RStudio and R library management. We will also try to squeeze in Chinook for data management. We will keep that as a separate recording. We'll try to fit that into the morning session. If not, we will add it into the afternoon session. A quick word about the afternoon session. We will be having showing you the core skills practical exam. And a note about that exam, it is open note, open book. You do not have to come in person or even be online during the afternoon session to take the exam. It is just something that we encourage you to try. And if you can complete it by the end of the workshop, then you'll get a badge for its completion. Again, this is not something that has to be completed within the scope of the workshop, and we'll learn more about that this afternoon. Something to note that the afternoon session is more of an open help session, both for content we've covered so far, as well as people getting started on the practical exam. So with that, we will jump in to RStudio and R library management. So first, we would like to begin by acknowledging the land on which we gather is the traditional, ancestral, and unceded territory of the Musqueam people here at UBC. And the copyright information for this content is CC. On the back. Whoa. Whoops. There we are. Now we're on the screen behind me. Okay. So the copyright information for today is CC BY SA 4.0. This is an attribution share alike license, which means you are free to share or adapt this content under the following terms that you attribute us as the original creators, and any content you create inherits the same license. If you're interested, please learn more by clicking down there at the bottom. So how to get help during these sessions. So in person today, we have Haley and Jeff as our TAs, and online we have several people who will help you, namely Carly, who has really been leading things, but also members of the ARC team, including Jerry, will also be online. So if you are in online, we encourage you to use this code share link here for July 27th, and you should be able to post your questions here. If you feel so inclined, you can also sign in. And when you're asking your questions, you will post your questions here, trying to follow the format described, and they will be answered by the TAs. I've also noticed that several questions have been answered and asked in the chat for the Zoom. The benefit here is that the Zoom chat will also have a recording. So we will be able to share the text from the Zoom chat in case there was some code or answers pasted there that you were not able to write down. So the learning outcomes for today, at the end of this session, you'll be able to manage your own RStudio directory on Sockeye, install R libraries relevant for bioinformatic analyses, launch RStudio on Sockeye, and then launch an Rscript inside a job submitted to the scheduler. A brief outline for today. Here you can see Sherlock almost in his full form, and Rosie. So we're going to first talk about defining R in RStudio, including some exciting news from this morning, setting up your own RStudio directory, downloading R libraries, running RStudio, and then running R from a job script. Starting with defining R in RStudio. So R is a software or programming language. There are other languages that include Bash, which we've been working on so far, Python, C++, Julia, Rust, a new one called Carbon, Go, Nim, Java, JavaScript, Fortran, and there are many, many others. Now, most software is developed using what we call an integrated development environment, or an IDE, that knows the software language or the programming language and can help you visualize and debug during the software development process. RStudio is the most popular IDE for developing software in R, and it also has the capability to use other languages like Python in code chunks. And some of the content that you'll see later in the applied sessions will have examples of mixed R and Python code chunks. Now, programmers across the globe are creating R libraries or packages. And we can think of these as bundles of code that execute specific tasks. Many times, these libraries or packages are optimized, meaning that the code is sometimes written in other languages, but will be able to be used in R. Examples for different libraries could include tasks like performing statistical analyses, analyzing, or transforming your data. And we'll see several examples of those in the applied sessions. Now, do you have to run RStudio on Sockeye? No, absolutely not. In fact, RStudio really works best on your own computer. And for the RNA-seq workshop, you will actually need to set this up on your own computer. So if you're attending that workshop, and we'll also communicate this through the Slack and through email, please explore these prerequisites for setting up R and RStudio on your own laptop or desktop. It's very straightforward. And a quick plug, and here's the big news: RStudio will cease to exist. So mentioned this morning, I guess actually in the afternoon in London, on just so happens to be the same day we run this workshop, an announcement was made that RStudio is rebranding as something called Posit. You can read more about that here. I don't know why they picked that name. Typically, when I discuss RStudio, it's just the first three letters, but that's not relevant. Here is Nikita, who just happens to be at that conference and is able to get some new swag, including stickers for Posit. Maybe she can bring some for us. We'll see. So the flow of RStudio. So we're used to seeing this diagram of Sockeye. And so here I'm showing you the kind of steps of what we're going to be accomplishing. So from the head node or the login node, where we first log into Sockeye, we are going to fetch the RStudio Docker container from the internet. So it's on the internet on the Docker hub, and we're going to use the singularity pull command to copy that to the storage space. Once we have the Singularity RStudio container on the storage space, we are going to execute it in order to download our libraries from the internet. We're going to still be on the login node when we're doing this because we need access to the internet. Once we have our libraries set up, we will submit an RStudio job to get a compute node. And so now we will be on the compute node with our Singularity RStudio image, and we will have a certain amount of CPU and memory available to us on our job on the compute node. Then from the compute node, there will be half of a connection that will be put out just into the internet for us to tap into. Now, this connection is not enough to run RStudio alone. We will then have to open a new terminal on our own computer, as well as a web browser like Safari. And then we will log into that open connection. And then once that connection is live and we log in through the web portal, we will be running our RStudio job on the compute node, visualizing it on our computer. So when we write files or when we process data, we're not actually on our laptop. We're just using this as a portal to connect to the compute node where the data and the R libraries are living on the storage space. Are there any questions about the flow of RStudio? I think this is something that's challenging to conceptualize because there are many steps. I think if you can see it visually, you'll have a better idea of how this translates to the commands that we're going to be running.
Here, the RStudio generally takes some computational resources we'll use it. And before, for example, if we want to run a job, we use queue sub something to get a queue and waiting for the resource. And for this kind of portals like Safari working, do we need the waiting or something like that?
Yeah, so the question is about submitting an RStudio job where we specify resources, and you will need to wait for that job to be accepted before this connection can be put out. So the connection from the RStudio container will not go live until your job has been accepted by the queue and you're actually on the compute node.
But this kind of Safari thing, maybe it's also interactive. So we have no idea how much time do we need. So we just apply one day or something.
Yeah, so the question is about how much time do you need if you're going to be requesting a resource. So I would say the best practice would be to do no more than as much as you're going to be actively working in a single day. So if that's 4 hours, if that's 6 hours, if you're crazy and you code straight for 8 hours, then that would be a fine time limit to set. Now, if you set an 8 or a 24-hour time limit and you only use RStudio for 10 minutes and you forget to cancel the job, you're still going to be hogging those resources. So I would always err on the side of shorter RStudio wall time requests. Any other questions about this RStudio setup? So it's also important to remember the main reason we would ever go about doing this, as opposed to just opening RStudio on our local machine, is that there could be times when RStudio, when we need more resources than are available to us on our local machine, or when the data sensitivity is such that we are not allowed to process that data on our local machine. So those are two scenarios in which launching RStudio from Sockeye would be relevant. But if you're simply plotting matrix data from summarized counts or processing data which is not sensitive and can fit within the scope of your laptop's resources, I recommend to just use RStudio on your local desktop or laptop. And you'll get some experience with that in Nikita's workshop. Question? No? Hair scratch?
Sort of.
Yeah.
So the entire job for the R script will be the entire script, right? It's not a single command. So for example, because within your R script, you have several commands until you reach the end.
Mm-hmm.
So you really need to polish your R scripts to submit it, because otherwise, if there's a bunch of errors that you didn't predict beforehand, you get your job basically will be a waste of time.
Okay, so what you're talking about, so the question is about whether or not you need to have a polished R script. So I think the best development flow would be to use something like RStudio, which is an interactive environment. So it's not just about submitting and executing processes. So when we open this, we're able to develop code interactively on this job. Now, once you get to a point where your code is polished and maybe it's ready for scale or production, then you translate that into an R script And at the end of this session, we're going to show you how, again, you would just take that R script with a job and send it to the scheduler. It would create a space on a compute node with the resources you request, and then just execute every line and finish. So there's kind of two sides of R and Rstudio that we're going to explore today. One is the integrated development environment, RStudio, and then the other is when you get something that you're ready to run and you want to just send it, walk away, and come back 8 hours when it's finished processing. That is just submitting an R script. So we'll see both sides of that. Good question. Something to mention is that there are some brand new docs explaining the process we're going through today. I encourage you to explore those docs for extra information, as well as to receive the periodic updates that the ARC team provides for those docs. And you can find those docs if we click this link here. This is just going to be on the side under using Sockeye, software, RStudio with Singularity, and this special case that we're going to explore today for bioinformatics, bioconductor Singularity. Setting up your own RStudio directory. So now we're ready to get into some of the hands-on content. We will be opening up RStudio. So first we're going to log into Sockeye. Ooh. Okay. So now that we're logged into Sockeye, we can go ahead and make ourselves a directory in the student spaces subdirectory. So for those of you who are new to the workshop, we've been creating a space on Sockeye here in /scratch/tr precision health 1/workshops/student spaces followed by $user. So this is going to translate into your CWL or your username. So if we run this command, we can then change to this directory. And if you've been following along, we have multiple different directories from the workshops that we've been going through so far. So the next command we're going to do is we're going to run a copy of the core RStudio directory from the project space into this current working directory. So we can copy that command. It's going to take a little while, and I'll show you why. We can then change into core RStudio, and we can run ls. Now, when we run or when we set up RStudio for the first time, we're going to be running this get rstudio.sh script. So you can see there's a get rstudio script, run rstudio script, and a run R script, as well as an install rlibs.sh script. Now, typically, if we were setting this up for the first time and not having 70 people run a command at the same time, we could run this get RStudio script, which would load Singularity, and then it would change to our home directory, which right now is just going to be in where we are. It would then make a subdirectory for our libraries, but you can see you've already got that subdirectory. And then it would run Singularity pull. It would create a RStudio bioconductor with a specific release.sif, which is going to be the Singularity image. and it would pull it from here on Docker. Now, there are several versions available on Bioconductor, and we could explore those if you want to here. So under the tags for Bioconductor, we can see there's release 3.15, release 3.14, 3.13, 3.12. And by clicking on each of these releases, you can scroll down and you can see what is the R version that is associated to a given release. So if you need a specific version of R, you can explore these different releases to find the version that will match your needs. Now, the reason we're not running this is because we learned yesterday, if everyone runs Singularity Pull at the same time, we might have problems. So instead, I've already run this command, and you have in your directory already the output, which is going to be this RStudio Bioconductor release 3.15.sif. So right now, your directory, which should be something like Scratch, TR Precision Health 1, Workshops, Student Spaces, Richmond P, Core RStudio, should look just like this. Does anyone have problems getting that set up? Cool. So again, if we were setting this up for the first time, for example, in your own allocation, you would start by running get RStudio. We're not going to do that today. Optionally, we could also explore the RStudio container, and we're not going to explore that today either. But if you wanted to, on your own time, you can load these modules, and then you can type Singularity shell. Now, this is something we were trying to execute yesterday, but ran into load issues when we were running this all on the login node. So if you run Singularity shell on the SIF file, it is going to enter you into the container. So now you will be on the container command line. You can type which R, and it'll show you where the R is. You can type ls/user/bin, which I will tell you is where the R is stored. And you could type which R script. Now, again, from yesterday, we covered Singularity containers, and it's important to remember that what's inside the container is different than what's on sockeye. So when we execute this container, we are going to be using an R and an R script and an RStudio that are already built within the container. Now, one question could be, why would we care about this Bioconductor Docker container? Well, if we go to GitHub, we can see that these Docker containers, they have why use containers, what's available, but I will just quickly show you the main reason why we use this container is that if you've tried to install R libraries in the past, you've probably gotten issues about not having certain dependencies. Now, those dependencies are all installed for you into this specific container by this script that runs when the container is built. So if you're wondering why it's possible to install certain libraries that are more tricky to install otherwise, this is the reason, is because this container has these sysdeps or system dependencies already installed. So we thank Bioconductor for doing that for us. Next, we're going to download some R libraries. So if we take a look at this install rlibs.sh script, so from here we can ls, we can cat it to the screen, install rlibs.sh. Now what this is going to do is it's going to start with module loads to get Singularity in your environment. Then it is going to create or point to a home directory, which is where we currently are. Now, if you're setting this up for yourself on your own allocation, you'd need to modify this to be whatever your directory is where you're storing RStudio. We have a lib directory, which is going to be here, rlibs 4.2.0. And I recommend making this for each Bioconductor release that you may use. So we know that bioconductor release 315 utilizes R 4.2.0. The next thing that's going to happen is we're going to run the singularity exec command. So we're going to see this a couple times when we get into launching RStudio, as well as when we get into running an R script. Yeah. So this is the version of R. So this is release 315. So yes, this is a good question. You could make an rlibs underscore bioconductor release 315, and that would also be good practice. Now I know that rlibs, that the version of R in this container is 4.2.0. Yeah, so whatever you name this directory, it doesn't matter. But you need to make sure that if you're going to be using R, it's important to know what version of R you're using. And this is just a good way to synchronize what we know the version of R is inside this container with our... Yeah, so if we go to this bioconductor singularity containers, and we were to click on release 315, we can see that the R version is 4.2.0.
This 3.15 is our version of the bioconductor.
Well, it's not really a version of anything. It's just a release tag. Yeah. They could call, I don't know how they have this version. I don't know what 3_15 means, but yeah, that's, yeah. Okay. So when we're looking at this R script, or this install rlibs script, we can see that what it's going to do is it's going to launch this singularity exec command. And what this is going to do, again, we're all on the login node when we're running this, is it's going to essentially enter us into the R command line. And then we will type, as soon as we get into that R command line, code that will look something like this, although we will need to make sure that this path is going to match to our directory for the rlibs. So let's go ahead and launch that install rlibs script. So we can do this just from the command line with sh. Oh, whoops. And I forgot to make that modification. So let's see. Install rlibs. I misspelled software collection. So go ahead. This is good practice for editing files. Instead of software collection, it's software underscore collection. And then hit Control O, enter, Control X to quit. So I will copy that install rlibs back to where it went. All right, so again, we ran into an error. It's fun to run into errors live, not really. But the error that we had was that it did not know what software collection /2019 was, because I was missing that underscore. So now if we run sh on install rlibs, after modifying this, it's going to look something a little bit more like this. Again, it's important to mention when you're developing or working on Sockeye, even if you've been working on Sockeye for a long time, you will always run into errors. It's how we confront those errors that changes whether or not we quit and throw up our hands. So now you can see, if any of you have used the R console, I think most days or most R teaching now comes through RStudio. But if you were back in the day ever using the R console, this is what it looked like pre-RStudio. So from the R console, we can type commands like get WD, which will get your working directory. And it will show us that we are currently in this working directory. We can also look at what are the current lib paths. Now, lib paths are going to be essentially a variable. It's actually an array that contains the different places where libraries are installed. Now, because we want to use libraries that are installed in our core RStudio directory, what we're going to do is we are going to set that. So we do .lib paths, .lib paths, and we can copy this and make sure you change Richmond P out to be your username. Notice that the $user will not work in this space. So this is something where you actually have to and make sure that you change. If you're copying from the slides, you'll notice that the little apostrophe there, the little quote, does not work. So you should type something that will look like this: .libpaths with an S /scratch /tr precision health 1 /workshops /student spaces. Put your username, core RStudio, rlibs 4.2.0. And it found some character it didn't like. This is what happens when we copy and paste sometimes. So if you have to type this out explicitly, all right, we're just going to type it out the whole way. So .libpaths /scratch /tr precision health 1 workshops student spaces Richmond P core RStudio rlibs 4.2.0. There we go. Now, if we look at our lib paths again, we can see that it's now recognizing this as a valid lib path. So again, those of you that tried to copy and paste, we can see there are times where copying and pasting does not work. And this is one of those examples. Okay. So now that we've got our lib paths set, we are ready to install some libraries. Now, we figured out the hard way that R version 4.2.0 does not come with certain packages that it used to. So if we want to use this bioconductor package, we need to install these packages here. So we can go ahead and just type those in because we've just noticed that running with copying and pasting is not our friend today. So install.packages are markdown. Now, when we hit enter, you can see that it's going to be installing that package into this library spot on this library directory on Sockeye, which is where we want it to go. Here it's installing the SAS binary. And then it finishes. It is done with our markdown. And now we have the R markdown library. So let's go ahead and install some more packages, including markdown, install packages HTML tools, install packages base 64 enc. Okay, so now we've got a few packages, but let's say we wanted to install some bioinformatics libraries or packages. So we start by loading the BioC manager library. We can see, oh, that's why bioconductor version 3.15. There you go. So bioconductor version 3.15 is now loaded, and you can notice that we didn't actually install bioconductor. So how do we have it? Well, that was installed into the container for us. So when we pulled it from the cloud, bioconductor was already in the container. We did not have to install it. Now, in some of the workshops that you'll be attending later on, including this Friday, it's possible that the workshop leaders have installed these packages inside of the containers themselves. This is not something that we are going to cover, but it is possible. So now that we've loaded BioC Manager, we can type BioC Manager install, and let's go ahead and install the DESeek2 package. Now, DESeek2 is a popular package for differential expression analysis in bulk RNA-seq. And some of you may use it for your own research. So right now, Bioconductor is installing this bioinformatic library. And in the problem set, you'll be able to explore trying to install different libraries. And I encourage you to try and install a library that you may need for your own research. So while we wait for these packages to finish installing, we can take any questions. Are there any questions from the room or from Zoom? Yeah, you have to. So if those of you who maybe were just slightly behind, we had to modify our R install our packages script. In fact, if you can recopy it now.
Yeah. Modify here and still converting C files and box.
Oh, then it's just running. It's just waiting.
I pressed like start like within seconds of like needed, it's still.
Yeah, so for those of you who might be experiencing some issues actively running the step here, sh install rlibs, that could be due to the fact that many of us are running the command at the same time. Now, one thing that you can do is you could look at what your login is. So another option that we might be able to explore would be logging in to a specific login node. So there's login 01, 02, and 03. And if we happen to be all on the same login, then this could be a little bit slower. If you are installing packages and you get to this spot, you can hit A. We'll update all of the packages that we need to update. Login 03 is doing well.
Hers installed immediately. I'm on one. Yeah, I'm still logging 3.
I don't know.
Oh, never
She skipped the line.
Yeah.
Okay. So one of the things to recognize is that there are many of us trying to run this at the same time. So if this is not working well, then you can always just watch because it's worked for me. And now I will be able to run the next steps. So just go ahead and follow along. And then we can have some open time where some of us will be staggered. Yeah.
I just have a question. Mine is I should update.
All. Yeah. If you'd asked for you to update ASN, just do all.
Sorry, I've been distracted trying to install this and thoughts. Could you briefly go over the last, step 4 and 5? So we know what you tell us what you did. I'm sorry, I was.
Yes, it's also important to recognize this content is recorded, so I recommend going through it again at your own pace. But to recap what we've done, we created a space for RStudio. We didn't run get RStudio because I already had that for you. We then ran install rlibs, which entered us into the Singularity shell and into the R command line inside the container. We set our lib paths here so that when we install libraries with the install packages commands, they're going to go to this space on sockeye, which is very important. And then we installed packages with the classic install.packages followed by the name of the package. Now, once we're done with that, we can test to see if our package installed correctly. Do you have the same R bioconductor image? Oh, you probably spelt it wrong. Okay. So we loaded now the DE-seek2 package. And we can see we now have DE-seek2 transform, DE-seek2 dataset, DE-seek. So we can now use this package in our RStudio session we're about to launch. So I will type Q. This will clean up the image. If we type ls, we can see that if we list out this R libs directory, it's going to have those libraries that we just installed, including DE-seek2.
Sorry, so the cleanup step, that's an important thing to do, or what?
Are you talking about this?
Yeah.
Oh, no, it just does that by default. That's just me quitting the image. So when you hit Q, it's going to leave that interactive container and it's going to put you back on sockeye. Okay, we can maybe take a quick pause. Let's see. All righty. So now we are going to run RStudio. If you were not able to get this to launch, you can open up a new terminal, or you can simply hit Control-C, and that will kill your install rlibs script. So you can see here I'm on login 02. You could also log in to login 03. But again, if too many people are running the same exact command at the same time on the login node, this can be an issue. So now let's talk about running RStudio. So again, we exited R, which will quit the container with the Q. All right, so now let's go ahead and look at the run rstudio.sh script. So this run rstudio.sh script is going to start like all of these other scripts do, job scripts do, where we have a header. And in the header, we are asking for 3 hours of wall time. We want one node will take 4 CPUs and 24 gigabytes of RAM. We're going to load Singularity from the module stack. We're going to set different directories. And then we are going to bind those directories inside our container. You can also notice that we are pointing to the library directory where we've installed libraries, and we can list that out to make sure it exists. It does, and it's got the libraries we need. We can also list out the rstudio.sif file to make sure that that exists. And it does. So now what I will be able to do is we will run qsub run rstudio.sh. Now, if we list out the files that were just made, we can see that there is now a connection file. And we can concatenate that connection file to the screen. Now you'll note that the connection file is going to be specific to the job that you're running, which means that if you were to type qsub, that your connection file would be named slightly different from mine. And the contents are going to be different as well. So for me, if we look at this connection file, we can follow these instructions. So it says the first instruction is to create an SSH tunnel to RStudio server from your local workstation. So breaking this down, what is a local workstation? That's going to be my laptop. And an SSH tunnel to the server means I'm going to need to open up a new terminal. I'm not going to log in to Sockeye on this terminal, but I am going to copy this command. Oops. We can also run a qstat-u on our username to make sure that RStudio is indeed running. And in this new terminal, I'll even use my fancy touch bar and make it a different color. We can run this command. So again, this command is going to be in your connection file. So when I run this command, it's going to ask me to log in. It's then going to ask for my passcode. Do authentication. And it's going to look like it's just hanging. This means you've done something right. So while this is hanging, I'm just going to go ahead and minimize it. This is what we did. It's going to look like it's stuck. Perfect. Now you can open your web browser and point it to localhost 8787. So we can copy that. Why don't we go ahead and open a new web browser? And now we have the RStudio login portal. Now the username and password for this are also going to be specific to this session. So my username is going to be shown here. This will always be Richmond P. And my password is, this is not going to be my Sockeye password. It's going to be this password. Make sure you copy the whole password. Hit enter. There's no point in remembering that password. And voila, we have our studio. Vigorous calisthenics. So some steps just kind of in the slides, you can see what we were doing. We copied this into a new terminal. We pointed our web browser to the local host. We entered in our username and whatever the password was here. And voila, we have RStudio. So how many people in the room were able to get to this point? Okay. Not a lot of hands going up in the room. So where are people getting stuck?
I'm running for the libraries.
Oh, so some people are still installing libraries? Okay. Okay, so if you're still installing libraries, that's okay. You'll notice that as those of us who finished our libraries stopped our Singularity jobs, or essentially stopped running Singularity on the head node or the login node, you are then able to run those install scripts yourself. So we'll just pause here. See if are there any questions in the chat? Doesn't look like it. Okay. Now, the first thing that we're going to need to do once you're in the RStudio with this bioconductor release is that we know that Markdown does not exist in this version of R. So instead, we have to start by pointing to the lib paths. So if we type get WD in RStudio, we can see that, again, we are here on sockeye. Now, if I type .lib paths, you can see it's not recognizing that library path that we had made. So we need to add it. So I will do .lib paths, open /scratch, strv1, workshops, student spaces, Richmond P, core RStudio, and I believe it's called rlibs 4.2.0. So now if I check my .lib paths again, you can see that that path is included. And again, if we're on sockeye and we list out that path, this is where our libraries are going to be. So back in the RStudio environment, we can now run a library on DE, and you can see one of the advantages of the integrated development environment is that it's already shown me my options. So I can now load the library DE-seek2. If we come back to the slides, that's what's happening on this slide here. And voila, I now have DE-seek2 running in RStudio that is actually running from one of the compute nodes of sockeye. This is a real inception process. So now we can open a new Markdown file. So here at the top, we can go File, New File, R Markdown, and we can title this file, what do I call it? My DE-seek2 analysis. Written by Sherlock. I hit OK. So now I've got a new R Markdown file. Now I'm not going to go into detail about what an R Markdown file is, but just recognize you'll be seeing several of these in the applied workshops that use R or RStudio. Now in this R Markdown file, let's say I want a code chunk I could scroll down here, and I don't really care about a summary of cars. I can instead run a library DEC2. And if I execute that code chunk, it's going to be able to load that library in my R Markdown. So let's say I've gotten to a place where I'm happy with my progress and I'm ready to call it a day. I can now save. And it's going to ask me, where do I want to save this file? And you'll notice that the options are going to be for files that are on Sockeye. So I will call this the best DESeek2 script ever. The best DESeek2 script ever. And this is a .rmd, an R markdown. And I will save it. And now if we pop back over to the Sockeye terminal and we type our favorite ls command, we can see that we've created this new R markdown script. So in this way, as we are working in RStudio, developing our code and making the best R script ever, or the best DESeek2 script ever, those changes are going to save directly to the Sockeye Scratch system. So if we come back to the slides, we've saved, and all good things must come to an end. So we can come up here to this little red dot, and it's important that you quit every time correctly. So we are going to come up to this little red button. We're going to quit the R session, and you should never save your workspace image. Don't save. Now this is killed. We can cancel that, but we're not done shutting things down. We also have this other terminal, and we will go ahead and Control C to cancel that. And I will close that terminal. And we're still not done, because if we look qstat-u $user, we still have our job running. So we can type qdel on our job identifier. And now this is going to take a minute to register, but I asked it to kill. It'll happen. And recognize this is going to be different for your job. Anyways, it's going to finish its qdel. So yeah, are there any questions about RStudio? Maybe before we get into questions, I will go ahead and talk about some common issues. So one issue is that you run out of memory. Sometimes we're dealing with big data sets, and we might have underestimated the memory or the RAM that we need in order to store those data sets in very inefficient R objects. So if we've got R running in RStudio and we've asked for 10 gigabytes of RAM, and we need to load into memory a spreadsheet or a CSV that is 50 gigabytes large, we will get the spinning wheel of death. So the solution is that you're going to need to relaunch the Run RStudio job with more memory. Now, when you get the spinning wheel of death from either running out of memory or not closing RStudio correctly, you're going to have files created in this .local share RStudio for wherever your home directory is set. Let's just make sure that died. So that job did get killed. Now you'll notice why I like ls-al-htr. Again, this order of commands does not matter. But what this shows is that the A is showing me my hidden files. So these hidden files like .local, if we change into .local, We can ls, we can change into share, and we can change into RStudio. The files in this directory can be deleted. And so we can do an rm-rf of this .local share RStudio. And what this will do is if there is some hanging signal from our RStudio session that failed or that had the spinning wheel of death, we can clean this folder out and then refresh on the web page. Lastly, you might get an issue that the job will not hold in the queue. And some solutions to this are, first of all, consult the documentation to make sure that you're running your job as specified and as suggested. And if you are trying a different container, for example, you may need to check the version of the Singularity and the current rules for the includes in the Singularity command. So you may notice if we look at RStudio with Singularity, there are some notes about the version of our Singularity and what you have to include in this Singularity exec command. And again, if you're running into issues, I encourage you to consult these documentation. If you still have an issue, then the ARC support team is very well equipped to fix or to understand your problem. Any questions from RStudio? How many of us got RStudio to work? Yeah? Okay. There are a few in person that got it to work. Hopefully some of you online got it to work. And again, if you're not able to get it to work for you immediately, you are more than welcome to revisit this at another time. Yep.
What was the reason behind the not saving the workspace image to .r data?
So your workspace image, the best practice is to clean out the environment from everything that you've been doing. So your workspace image is storing things like your variables or data that you've loaded into memory, right? So if you open it up again, it's going to try and tap into that workspace image, and it could cause conflicts with launching the RStudio. So best practice, just don't save the workspace image. And every time you open a new RStudio session, you should be able to go through a set of steps running your own code chunks in order to get to where you left off. So this is more of a programming paradigm problem. So the same problem with Jupyter and RStudio is that you don't have to execute the code starting at the top, going all the way to the bottom. You can execute a code chunk at the top, and then one in the middle, and then one at the bottom, and then back in the middle, and then back at the top. And what ends up happening is that it's hard to reproduce the set of operations that you ran in order to get to maybe a plot that you made. So the best practice would be to always set up your Markdown or your Jupyter or your RStudio script so that you're running operations for starting at the top, moving down. And if you get to maybe 5 or 6 steps and you're done for the day, you're going to clean out the environment. You're not going to save the workspace image. And when you open it again, you'll be able to start at the top, run those steps, and pick up where you left off. Okay. Any other questions before we get into Rscript? Cool. All right. So we are already set up to run R through the container, which is how we were downloading our R libraries. And we've also already installed those R libraries. So now what we can do is run an R script. So what we will do is let's go ahead and take a look at our files that we're going to run. Oops. question in the chat. So the question from the chat is, if we realize we need to install another library while we are already working on RStudio, what should we do? This is a great question. I would say the best thing to do would be to shut down RStudio, install the library, and then launch it again. Now, it could be possible that you could open up, you could run that install script. It could install it into the library path, and you could maybe automatically get it in RStudio, but that's not something I've tried. Any input on this, Jeff?
Just answering another question.
Oh.
Yeah.
So if you need a package while you're already in RStudio, could you install that package on a separate terminal to the lib path and then be ready to use it in RStudio?
I haven't tried it. Theoretically, it should work.
Yeah.
Typically, I've just terminated the session and started a new one, which is a bit of a pain.
Yeah.
Yeah, so I can't speak to it.
Mhm.
But it should work.
Yeah.
The only thing is, yeah, you wouldn't be able to do it through the RStudio session because while it looks like you're connected to the internet, you're actually not.
Yeah. So just to reiterate what Jeff was saying is that it might be possible, and we encourage you to try this, Charisse. You could open up, for example, if I had RStudio running, you could run this install rlibs. You could install a library that would get installed into here, and it should be available in the RStudio portal. However, what you cannot do is you cannot be in RStudio and type install.packages because you are not connected to the internet in that RStudio session. So I encourage you to try it and report back. Okay. So coming back to our script. So what we're, since we were previously, if we think about what we were doing previously, go back to our lovely image up here. Previously, we were launching an RStudio job on the compute nodes. It opened up a portal. We connected to that portal on our local machine. Now, if you've got something that's going to run for more than 4 or 5 hours, what I recommend you do is develop the code to get it to a place where you're confident it's going to work, and then put it into something like an R script and launch that R script as a job on the compute nodes. And we're going to show you how to do that with the greatest R script ever created. So first thing we're going to do is make sure we're in the right place. I'm in the right place. Scratch, TR Precision Health 1, Workshop, Student Spaces, Richmond P Core RStudio. We're going to make sure that we have our CIF file. We're going to make sure that we have our R libraries. We do. And now we can look at this run R script command. So let's go ahead and concatenate it to the screen. Now the run R script command, again, at the top, we have, this is a job script. So we have our resources that we need. We have the ability to load Singularity. We're setting a path to our RStudio CIF. We are setting our home directory and a directory for our libraries. Now we're also setting an RScript variable. Now you don't have to do this. You could just call your RScript variable in the code below, but this is a simple way to do it where we only have to make changes to this section. Now we're not going to modify any of the code below, but what you can see is that we are running Singularity exec. We're binding some paths. We are calling the RStudio CIF. And then from that CIF, instead of calling RStudio like we did before when we were running RStudio, and instead of calling R like we did when we were running our install R libraries, we are calling the rscript command. And the parameter for that, the only argument that's needed, is the actual R script. So let's take a look at this R script. It's a perfect R script. We first are going to need to set our lib paths so that we make sure we have access to the libraries. We'll then load the library DESeek2 that we know is there, and then we will print to the screen. So we can q sub our run rscript.sh. We can run qstat on our user to make sure that the job is running. And then we can see our run R script is going to have a .o and a .e. And we can take a look at that. And we can see what it printed to the output was that Sherlock is afraid of bees. He's very afraid of bees. He's also afraid of flies because they sound like bees. And we can also see that we loaded in our error, we were able to load the R or the DESeek2 package. And that is all we have for the R and Rstudio session. So I encourage you to explore more with the problem set, and we'll maybe take a few questions, and then we'll be able to go through the Chinook slides starting at 10:30. So if there's any questions or comments, feel free to ask. Yeah. Hopefully that visual walkthrough can accompany the many docs that exist, including documents here written by Eliza and Jeff, as well as we have documentation for this. If you go to Precision Health Virtual Environment, software, and then if you scroll down, we have an example of what we just ran. Now, keep in mind that some of the paths that are used in these examples are going to be different from what you might be using. This is just showing you that while we've been working inside of one directory for the workshop, you could also deploy this code in other directories, for example, in the sandbox or on your own allocation. Yep.
So related to the run RStudio, sometimes with big data, you have like the gigs and gigs of data in a CSV file. So would it be also best practice to host the CSV file in projects and run stuff from scratch? As implemented like yesterday, 2 days ago, like host the data within projects and run stuff from scratch.
Yes, you could do that. So if you do that, you're going to need to make sure that if your data is in a different directory, that you bind it inside the Singularity command. So if we look at our run RStudio command, we have different binds, right? So right now, the binds that I'm making are all on the scratch directory. So if I ask to list or to, read CSV from a file that's on project, it's going to tell me, I don't know what you're talking about. There's no such file. Now, if you bind the directory for data, for example, if you made this data directory somewhere on the project space, then you would be able to see that data. Now, you just have to be cautious that you're not trying to write to the project space, because you cannot write to project from the RStudio session. right? Because you're on the compute node. So as far as a best practice, so when you say gigs and gigs, what does that mean? 10 gigs, 500 gigs.
More than that. In our lab, we are getting some data from UK Biobank that is like 60,000 people.
Yep.
So
So if you're using something like UK Biobank data, then I do recommend that live only on the project space. You then bind the path to that, and you can read the data in RStudio there. Any other questions? The UK Biobank data is a great example of why you would need RStudio on Sockeye as opposed to running it on your local computer, because there's no way that a laptop has enough space for
Yeah.
the UK Biobank.
I've gotten that at some point, but I have a colleague who's already working on that, and just to load the data, it takes an hour.
It's also important to recognize if you're handling data that big, only set up your code for a subset of the data in RStudio and then get it to a point where you're ready to scale outside of RStudio. Because RStudio itself is a bit of a memory hog. It does not manage memory efficiently. So if you get your code to a point where you're ready for it to just run a set of operations, maybe make input and output files and clean up objects along the way, then that's an R script you're just going to submit. But even in the R script, right, you're going to still need to make sure that you're binding the path to the data. So the same rules about singularity and binding a path to data, to the home directory, to where your libraries are, those same rules apply for both Rscript and RStudio. Anything unanswered from the chat? What do we have in the chat? What is the best way to use RStudio and Git/GitHub for version control and collaborations? Would you recommend using R projects? Oof. That's a great question. I personally have never collaborated on R projects. I can say that RStudio for Git and GitHub, I mean, RStudio is just the development environment. So if you're using Git and GitHub, that would be to track things like edits you make to an R markdown. So I do recommend that if you are going to be doing any kind of code development in R markdown, what you could end up doing is having a GitHub repository where you're hosting things like the best DE-seek2 script ever made and your polished small R scripts that you're creating. So in that scenario, that's a good way to kind of version control as you work. Now, as far as R projects goes, I don't have enough experience. I don't know if anyone, Jeff, Jeff and I don't like R. I'll be quite frank with you. So maybe others on the call could answer that. So Sharice's question. So can you include multiple data directories, i.e. one that will read your data from a project folder and then one that will write to a Scratch folder? Yeah, absolutely. So if you recall from yesterday, when we were working in Singularity, we ended up having this command. So here, I have a database, the human reference genome, that lives on project in this directory. Now, the data that I'm actually going to be working with is on the Scratch directory. So what I do is I can bind as many directories as I want, including the temporary directory for the onboard SSD, the onboard disk for the node. You can bind all of those directories that you want with -b commands. So you could have 50 -b commands if you wanted. Here's kind of a cleaner way of showing it. Here I'm binding the working directory, that's on Scratch. Here I bind the FASTA directory, that's on project. And here I bind the temporary directory, that's the onboard disk. So you can bind these different paths and you can set it. The only thing I would recommend you make sure that you do in Core RStudio is that you need to make sure that you set your home directory to Scratch, because if your home directory is set to project, what it's going to do is it's going to try and create these temporary files, like the temporary directories, like the .local directory. And so if you run that on project, you're going to get into trouble. So yes, you can bind data from the Scratch and the project directories. You can only write to the project directory, but there's nothing that stops you from binding those paths. Okay. So we'll just take a quick 5-minute stretch. I will stop this recording for RStudio, and then we will start a new recording for Chinook, which will start at 10:30. So any other RStudio questions, feel free to yes. So in the RStudio command, the --home directory should be the folder you are writing to. Yes, ideally. You can write to different directories, but that home directory, when we open up RStudio, is going to be where your home sits, right? So the home directory set, that's ideally going to be where you're keeping data and code. So you could output to different files, right? So you could set it up where you were reading data from different directories and writing to different directories. You can be explicit about where you write your output path to, and you can write to anywhere on Sockeye as long as you have access to write there, and as long as you bind it into the container. Excellent questions. We will now stop the recording, and those of you looking for Chinook, we'll see you in just a few minutes. And those of you who are hoping to work on the core skills practical exam, we will see you at noon. Although that session, again, I'll be here. It's more of an open help session, so you can bring your problems from other workshops that we've hosted so far, and we will be here to assist you as you attempt to test your practical skills. So thank you, and see you in a few.